Now, what is research? Obviously, farmers are doing things in a different way. They're following a different model. The farmers we talk to like to compare last year with this year. This field with the one across the road, or a field across a fence line. They're not methods that we would consider, from a research standpoint, statistically valid. Yet, when you see things that are different, if they're grossly different, you believe those differences if you've done them yourself. There's nothing wrong with that, certainly. It's a very real experience. Farmers like to see large fields. They like to make minor modifications in their system that are not too costly. They like to see something that's cost-effective coming out as a result of this experiment. Those are all characteristics that farmers put credence in. They like something that's done very close to home or on their own farm. Now, what do researchers like? Researchers like small plots because they have control over more of the variability in that area. They like a number of treatments that are quite similar. Corn hybrids that may be genetically different but are similar in height, so that you don't confound the differences in reaction.
Skew the results.
Just to the height alone. Researchers insist on replication and randomization of the treatments. All of these allow us to use current statistical methods to analyze our results, to publish them in journals and so on. We believe those results, we as researchers. We as farmers sometimes question those results because they came off of garden plots, they came off of highly controlled areas, perhaps they were irrigated, and my farm is on dry land and so on. So what we have is a whole series of criteria here that farmers believe, another series of criteria that researchers believe, and sometimes they don't believe each other. Often they do, of course, but for purpose of argument, they're coming at it from a very different standpoint. Now, what the practical farmers of Iowa, our Nebraska Sustainable Ag Society, our farmer collaborators are doing is studying what researchers do. We as researchers are studying what they do. We're looking for ways to rationalize these differences so we can, in fact, do joint activities that meet all of our criteria, that we're both satisfied with. And this takes some interesting forms. Generally, it means long drive-through plots that are all the way across a quarter section, perhaps. They may be 1,100 feet long. They're usually 1 planter width wide or 2 planter widths wide, so you can drive down the field.
That's what you meant by drive-through?
Drive-through, yeah. Drive from one end of the field to the other, not have to stop every 30 or 50 feet, change treatments. So we're looking at ways to analyze these large-scale experiments that are replicated, that are randomized, and run our standard statistical analyses to see how credible these are. In fact, in analyzing results from on-farm activities in both Iowa and Nebraska, we found that these are very precise when you go across a long distance of field. We didn't know at first why they were precise. We still don't for sure, but we're quite convinced that the fact that we go across a lot of field variability, there's probably more variability from here to the other end of the field than there is from one plot to the next when they're side by side. So this is an integration of all that variability. That's a very nice comparison between those two treatments. So it's just an example of how we can use large plots, use full-sized equipment, use things that farmers design, and then analyze these results in a way that we find statistically meaningful, that fits the criteria of repeatability from our statistical standpoint.